for the first one, did you get 12 times the cos of 30? Cos of 90 plus I sine 90? Right, and they didn't say in rectangular form, so it's perfectly fine to leave your answer like that. Okay, if you put it into rectangular form, you'd get 12 plus naught I. Is that what you got? You probably left it, so right, did you? And here you get 9 divided by 6 is 3 over 2. So the answer is 3 over 2, and then you have to subtract that was 150, take away 60, 90. So 3 over 2 times cos of 90 plus I sine 90. Did you get that? Right, does anyone need me to write any of that out? Right, easy enough, isn't it? Right, one little bit on that section that I never did was, if we have the reciprocal, girls, of a complex number in polar form. So the reciprocal of a complex number in polar form. Remember, a reciprocal of 2 is 1 over 2. The reciprocal of 7 is 1 over 7. The reciprocal of 3 over 2 is 2 over 3. Right? So the reciprocal is put 1 over it. Right? Okay? So if I have a complex number and I want 1 over the complex number, now I could do a division there, couldn't I? Right? But in polar form, all you have to do is put 1 over the modulus and put a minus in front of the angle. Okay? Which means instead of going anti-clockwise with the angle, you're going clockwise with the angle. Okay? And you don't have to change the angle. You can leave it as minus whatever it is. Okay? So example 1, so here's the modulus, here's the argument. So all you have to do is put a 1 over the modulus, so it's 1 over 3, right? And instead of having 30, it's now minus 30. So it's a cos of minus 30, which means you go 30 degrees in the opposite direction, plus I sine of minus 30. So remember, the degrees just gives you the position on the plane. So basically we started off with a complex number that was 30 degrees that way, and when you get the reciprocal of it, you'll end up with a complex number that's 30 degrees that way. Okay, so that was your starting point. This is minus 30 degrees, means you just go in the opposite direction. Okay, is that right? Okay, so another way of saying minus 30 would be what? Plus 330. Right, so minus 30 and plus 330 are the exact same position, so you can say either. Okay? Right, are we okay with reciprocal? Right, the real point in polar form is to do powers. Right, okay? So while there's a shortcut there, right, the real shortcut is when I'm just going to show you, again, this is me just explaining what I'm going to do, don't write it down. Right, so if you had something like 2 plus 3i plus 3i all to the power of 4, right? So you'd have to go 2 plus 3i multiplied by 2 plus 3i multiplied by 2 plus 3i multiplied by 2 plus 3i. Okay, so you'd pick the first two brackets and you might multiply those out and get an answer. And you might multiply the second two brackets and get an answer, right? Okay, and then you'd multiply your two answers. It's a lot of work. Agreed? There's even more work if I said to the power of 15. Would you agree? Would you be doing it that way? You certainly would not, right? Okay, because, right, aside from the 3 pages of paper you'd need, you'd surely make a mistake somewhere along the way, right? So there's a shortcut, and the shortcut is called De Moivre's theorem. Well, I say De Moivre's theorem. I don't know what other people say, other stuff, but we call him De Moivre in my class. So you can call him whatever you want, right? As long as you know how to do his theorem. So what it means is you put your complex number, if it's not given to in polar form, you write it in polar form if they want you to raise it to a power, right? So you put your complex number in polar form, and then to raise the complex number all to the power of n, so if you want to raise all the complex number to the power of n, you raise the modulus to the power of n, and you multiply the angles by n. So you multiply whatever the angle, so it's n theta, you multiply it by n, and you multiply that angle by n. Right, we'll see an example in a minute now, and it'll make a lot more sense. And De Moivre's theorem is in the log tables, right? I'll just show you. It's under the algebra section, right? Okay, and it's the quadratic. It's on the page with the quadratic formula. It's down there. Okay, don't mind that bit at the end. So there, it's written there, just so you know it's there, right? So De Moivre's theorem is in the log tables on page 20. Okay, right? Not that, just so you know. Right, so you raise the modulus to the power, whatever that power is, and whatever that power is, you multiply the angles by, right? Example, here we have z equals 3 times the cos of 18 plus I sine of 18. Okay, so you want to raise that all to the power of 5. Because they want z to the power of 5. So all you do is, it's the modulus 3 to the power of 5 multiplied by the cos of 5 times, you multiply the angle by 5. So it's 5 multiplied by 18 plus I sine 5 multiplied by 18. Is that okay? So 3 to the power of 5, 3 is 81, 243, 729, I think. And it's the cos of 5 times 18 is 90 plus I sine of 90. And it says express it in the form a plus bi, so back into rectangular form. So on your calculator, you get the cos of 90. 3 to the power of 5, yeah. Which I think is 729. Is it 3 by 3 is 9 by 3? The 243? I did 3 to the power of 6, sorry. 243. Okay, Right, so into the calculator with that, or get your cos of 90 and get your sine of 90. What did I do with my duster? So that would be 243 times the cos of 90 is 0. So that's 0. And the sine of 90 is 1. So plus I times 1 and multiply into the bracket. So that's 0 plus 243i. Is that okay? Happy with that? Lovely shortcut. Yeah? Okay? Really helpful shortcut. Okay? So anytime you see a complex number raised to a power, you have to put it into polar form and then apply De Moivre's theorem. Okay? So I have an example of that now. Is that got down? Am I okay? Everyone's okay? Scream if you're not. Right? So express 4 minus 4i in polar form. So that's what we were doing yesterday. And hence find 4 minus 4i all to the power of 5. That's what we're doing today. Okay? So the first thing I need to do is get the modulus. So r is equal to the square root of a squared plus b squared, which is 4 squared, plus minus 4 squared, which is root 32. And if you do that in the calculator, it'd be 4 root 2, I think. That's the modulus. Is that right? Okay. Then I need a quick sketch to work out the argument. Okay, so that's across 4 down to minus 4. So it will be over here. So it will be across 4 and it would be down at minus 4. So I need to make a right angle triangle. There's my right angle triangle. I need to find x. So when I find the x, I'll either be leaving it as a minus, right, or I'll be taking it away from 360. Agreed? Okay, so the tan of x, so right angle triangle, I'll just draw it out bigger. So this is 4, this is 4. Remember, when you're doing your right angle triangle, don't worry about the negatives. If you put in the negatives, you'll end up with the wrong answer. Okay, so it's just measurements of lines, so always take the positive. So you got tan of x is equal to opposite over adjacent, which is 4 over 4, which is 1. And then you get the inverse tan of 1, and the inverse tan of 1 is 45 degrees. So that means x is equal to 45 degrees. Okay? That means the argument is either to minus 45 degrees or, what's that, 315 degrees, isn't it? So I'll put it as 315 degrees. Is that okay? So then in polar form, that complex number would be 4 root 2 times the cos of 315 plus I sine. Is that okay? So then I need to raise that all to the power of 5. Okay? So I have to take my complex number, 4 root 2 times cos of 315 and the plan is to raise that all to the power of 5. Okay? So the rule is you raise, it's 4 root 2 all to the power of 5. And then you go cos of, that's power of 5 there, cos of 5 multiplied by the angle plus I sine 5 multiplied by the angle. Now the numbers are massive here, but we have a calculator, so it's fine. We don't need to worry about that. So 4 root 5 all to the power of 5. Anyone like to help me? Some massive number. Okay, we just do 4 to the power, no, actually, Yeah, I wish I picked a different question now, because that's, we do 4 to the power of 5 and tell me what the answer to 4 to the power of 5.
Excuse me, please, would Breeder Ryan, Patrick 6, come to reception at the bell, please? This is just a reminder to all students again that the fashion show is on next Thursday night in the Strand Hotel. That's the 7th of April. The tickets are €15 and they're on sale here every day at the office. Now, we sold out everything we had today. We're getting more tickets at 3:30. So they will be on sale again tomorrow morning. So anyone who wishes to buy a ticket, it's advisable to buy it early tomorrow and not leave it until Monday or Tuesday. Thank you.
And that's 1,024. So then it's the square root of 2 to the power of, oh no. What did I say, 1,024 was it? Oh. Yeah, so it's 1,024 multiplied by root 2 to the power of 5. Root 2 to the power of 5 is 2 by 2 is 4. 4 root 2, isn't it? 4 root 2. And then multiply 1,024 by 4. They won't be as hard as this. It's just I want to leave it in terms of, I made this one up. So that's why it's coming out weird. So it's 4096 root 2 when you multiply it out. As I say, don't worry about it. You just do it in the calculator. Right, okay? So then I do cos of 5 times 315. That's 1,575. Again, huge angle, but we have calculators. Sine of 1,575. If it does this in a decimal now, I'll go mad. So that's 1,570. Yeah, minus root 2 over 2. So that would be 4096 root 2 multiplied by minus root 2 over 2. Sorry, I picked terrible numbers to do the example, but it's just calculator work, okay, so don't worry about it. It's root 2 over 2. Okay, so I will multiply that by 4096 root 2. $4096, so that's 4096 plus 4096i, and that's your answer. Right, you'd have great crack trying to multiply that out with your eyes, wouldn't you? Right, that's the answer. Right, is that okay? Right, I know the numbers are huge, but don't worry about what happened at the end. It's just calculator work. Okay, right, I picked a number that was way too big. Okay, so what I'm going to do is I'm going to give you a few of those to do, right, and we'll see how we get on, and we'll iron out the problems tomorrow. So if we do page 33, let's do all of question 1, where you just have to multiply the angles, right, okay, and then let's do all of number 6, so 1 and 6.